I'm going to start. In this lab, okay, we are going to discuss about the routing concept. Okay, routing concept. So what do you mean by routing? Routing means, okay, we are going to send or sending the packet from one network to another network. Okay, so that is a concept of routing. So now in this topology diagram, that means in this lab, I'm going to create a topology diagram. So in this topology diagram, there will be more than one networks, okay, is going to available. Now let me take a switch. I'm taking a switch. Okay, so this is a switch, a 24 port switch I'm taking. So with this, I'm going to connect some host, some PC I'm going to connect. So I'm connecting 3 hosts here. Okay, 3 computers I connected in this topology. Sorry, in this I have 3 PCs. I selected 3 PCs here. Now I'm going to connect all the PCs with the switch. Okay, so this is my first local area network. So this is a small local area network. We can say it is a LAN. Then I'm going to have one more local area network I'm going to have here. So this is my second local area network, and here also I'm going to have few computers. Okay, for example, I'm going to have 3 hosts. Okay, there are 3 different hosts. I'm going to have it here, and this host I'm going to connect by using, okay, all the hosts I'm connecting to the switch. So our second topology, that means sorry, second local area network LAN is ready. Now I want to connect, okay, I want to connect these 2 local area network. Okay, I want to connect. So what I'm going to do means, if you want to connect, you need the routers. Okay, you need the routers. Okay, if I simply connect like this, okay, for example, I'm going to connect this switch, these 2 switches, I'm going to connect it directly. If I connect, okay, can I say it is connecting 2 networks? Means no. Now it is a single network. It is only one network. So okay, it is not 2 networks, it is going to be a single network. So this concept is not correct. So what I'm going to do means, I'm going to add some device. Okay, what is the device? Means the device is, okay, a router. A router is the device. So now I'm going to add some routers in between these devices. So router is a layer 3 device. Okay, router is a layer 3 device. So this device is used to connect different networks. Okay, we can connect different networks by using this device. Okay, I'm having some routers here. Now I put so many routers, and by using these routers we are going to connect. Now I'm going to make a topology. Now that means I'm going to connect all these devices. Now how I'm connecting means, from the switch I'm connecting to the router 4. Then this place, the switch 1, I'm going to connect it to the router 3. Then the other devices from router 4, okay, I'm going to connect it to the router 0. Then from router 0 to router 3 I'm connecting. Then from router 4 to router 1 I'm connecting. Then router 1 to router 2 I'm connecting. Then I'm connecting router 2 to router 3 I'm connecting. So you can see this is our topology, this is our local area network. This is one local area network. Okay, so this is one local area network. Then this is the another local area network. So the 2 local area networks I connected by using, okay, different routers. Now in this topology diagram, how many networks available? So totally how many number of networks available? So total number of networks. Okay, total number of networks. So how many networks available here means, so usually the students will tell 2, but it is not correct. So why it is not correct means, you can see this is one network, then from router to router this is a network. So routers are used to connect the network. So this is one network, and this is a network, this is a network, this is a network, and this is a network, this is a network. So totally how many networks available here means, so this is 1, 2, 3, 4, 5, 6, 7. So totally there are 7 different networks available in this case. Okay, 7 different networks available in this particular topology diagram. Okay, my concept, what I want to do means, I want to send the data from this network, from this local area network to this local area network, and I want to receive the data, reply. I want to get the reply back. So there are totally 7 networks available here. Okay, now the next concept is we have to fix the IP address. Okay, we have to fix the IP address. So how we can assign the IP address means, for 7 networks you have to take 7 different network IDs. For example, for network 1, okay, for network 1 I am going to take, for example, 10.0.0.0. So 10 network I am taking. So this is what we discussed in IP addressing. This is the network ID. Then for the second network, okay, so this is for network 1. For the second network, network 2, I am going to take 20.0.0.0. So this network I am going to take. Then for the third network, I am going to use the network, so 30.0.0.0. So like that I am going to continue like this. So till for 7 networks, the last network will be 70.0.0.0. Okay, I am going to continue like this. Okay, now you can see for this network, okay, I am fixing the network ID 10.0.0.0. Then here this is going to be 20.0.0.0 network. Okay, if you want you can use the word network. Then so this is 30.0.0.0 network. Then so this is I am going to have, okay, I am going to make it as 40.0.0.0 network, and then this one I am going to make it as 50.0.0.0 network, and this one I am going to make it as 60.0.0.0 network, 60 network. Then this is the 70 network, 70.0.0.0 network. So these are all the 7 networks available. I want to use these networks. Then the next step is you have to fix the IP address. Okay, we have to fix the IP address. So what is IP address means? This is 10 network. So I am going to use 10.1, 10.2, 10.3. Okay, and this place, okay, this is 10.4. Okay, you can see the mouse, okay, carefully. So for this also you have to give the IP address. This is fast Ethernet 0 by 0. Okay, now I am going to click the PC 0. I am going to the desktop, IP configuration. In IP configuration you can see I am giving 10.0.0.1 is the IP address. Then the next is subnet mask. Subnet mask is 255.0.0.0 because it is a class A IP address. Automatically the IP address, okay, that means subnet mask is generated here. Then the next very important thing is default gateway. So you have to fix the default gateway for all the machines, for PC 0, PC 1, PC 2, and here also PC 4, okay, 3, 4, 5. For everything you have to fix the default gateway. So what is the default gateway? Default gateway means the IP address of your router. Then only your packet will cross. It will go out. Otherwise your packet will be blocked here. So if there is no gateway, your packet will not move from your network. So I am going to fix the gateway. So 10.0.0. let it be 10. So whatever the IP address I am giving here, this is the IP address for your router. You have to give the same IP address to the router. If you are giving a different IP address, automatically there will be a conflict. Your packet will never move. It will never go out from this network. So I am giving 10.0.0.10 as the default gateway. Okay, now I am going for the next PC 1. So here desktop, IP configuration. Now the IP address is 10.0.0.2 is the IP address, subnet mask 255.0.0.0. Then the default gateway. So the default gateway is going to be the same. Please kindly don't change it. If you change, you will get the problem. So 10.0.0.10 is a default gateway. There, I am just going to close this. So go to the next one. The next one, I am going for the desktop IP configuration. Now 10.0.0.3 is IP address, okay, because this is the third machine. So 255.0.0.0 subnet mask. Then the default gateway is 10.0.0.10 is a default gateway. So I assign the IP address, okay, I assign the IP address for all the 3 PCs. We assign the IP address. Then the next one is we have to assign the IP address for this router, okay. This is our gateway for this network, okay. For 10 network, this is the gateway. Now if you keep your mouse here, it is showing FA 0 by 0. So FA 0 by 0 means, okay, that is the fast Ethernet. Fast Ethernet 0 by 0. Okay, now I am going to click this router. Okay, go to the config. Go to config. You can see fast Ethernet 0 by 0. Fast Ethernet 0 by 0. Okay, you have to select the correct interface. So the interface is going to be fast Ethernet 0 by 0. If you change the interface, okay, problem, the IP address will go to some other interface. So here I need, okay, for fast Ethernet 0 by 0. Now what is IP address means? Already we fixed the IP address. It should be 10.0.0.10, okay, because this is what we fixed for every computer. PC 0, PC 1, PC 2, we fixed 10.0.0.10. Now subnet mask and make the port status on. Okay, so 3 things you have to do. So fix the IP address, okay, then click the subnet mask, then make the port status on. So if you make the port status on, so automatically you can see, okay, it will be turned to green. Okay, it will be turned to green. Now so we completed, okay, for 10 network. So the completely, okay, what to say, the configuration, that means IP completely we have assigned. Okay, so we completed, only one network is completed here. Now I am going for this network. Okay, I am going for the 40 network. So for the 40 network, now I am going to assign the IP address. Now let me start from here, PC3. I am just going to click that, go to the desktop, IP configuration. So this is 40.0.0.1. Okay, I am going to take this is a 40 network. So first host, the first host ID is this 40.0.0.1 is a first host ID. Then next one, subnet mask 255.0.0.0, that is a subnet mask. The default gateway, so the default gateway I am going to fix 40.0.0.10 is a default gateway. Okay, so 40.0.0.10 only you have to give it for your router, for this particular place. You can see the mouse. So for this particular place you have to fix this IP address. Okay, that is your gateway. Now I go to the next machine, the second machine, PC4. So I am going for the desktop, IP configuration. So the IP address is 10 dot, sorry, not 10, okay, okay, try 10 and see what is happening. 10.0.0.2, okay, I am giving, but I am in 40 network. Okay, now you can see subnet mask, default gateway. So default gateway I am going to give 40.0.0.10, okay, is a okay, the default gateway I am giving. I just close this, okay, you can see this. Okay, it is accepting, but it should not accept. Okay, okay, the configuration is not completed. Okay, let me change it, no problem, I will show this later. So 40.0.0.2, okay, it should not accept, but it is accepting, okay, because all these connections are now off. If all these connections on, it will not accept. Okay, now 40.0.0.2 I am giving, okay, that is IP address. Then subnet mask 255.0.0.0. Then we are having the default gateway. The default gateway I have given 40.0.0.10. Now I am going for the next machine. So the next machine is PC5. Go to the desktop, IP configuration. So the IP address is, okay, so 40.0.0.3 is IP address. subnet mask 255.0.0.0, then the default gateway is 40.0.0.10 is a default gateway. So I completed for all the 3 PCs, we fix the IP address, okay, we completed. Now we have to go to this router, that means to fix the default gateway. Now you can see, if I keep the mouse on this, okay, interface, that is called the interface. Now it is showing FA 0 by 0. Okay, now click the router, go to config, go to fast Ethernet 0 by 0. Okay, go to fast Ethernet 0 by 0. So the IP address, what is IP address means? The IP address is 40.0.0.10 is IP address, subnet mask 255.0.0.0. Then you can make the port status on. Okay, you can make the port status on. So we completed, okay, these 2 networks, that means 10 network configuration, okay, we completed, and 40 network configuration we completed. Now in between there are so many networks available, so we have to configure these networks also. So if you are not configuring, you cannot send and receive the packet. Okay, you cannot send and receive the packet. Now I am going for one by one. Let me start from here, 20, 30, okay, then 50, 60, 70. So one by one we can go. Here this is a network, okay, from router to router is a network, but here there is no host, there is no computers. No problem, no problem, you can have a network like this. Now only 2 IP address will be used here. What is that means? This is 20 network. Now you can see, for this interface I am going to use 20.0.0.1 is IP address, I am going to use it here. Okay, then for this interface I am going to use 20.0.0.2 is IP address I am going to use here. The same thing here, this is 30 network, so 30.0.0.1, okay, so let me type, okay, then you can understand easily. So here 30.0.0.1 is IP address I am going to use, then here I am going to use 30.0.0.2. If you go for the next network, this is the 50 network, and this interface here, okay, for this interface I am going to use the IP address, I am going to assign the IP address 50.0.0.1, and for this particular interface I am going to use 50.0.0.2. Same here, 60. So for this interface I am going to assign 60.0.0.1, and for this interface I am going to assign 60.0.0.2, and here it is going to be 70.1, 70.0.0.1, and for this interface I am going to assign 70.0.0.2. Suppose if you are taking an exam, okay, lab exam, first you have to write all the IP address in a paper. You draw the topology diagram, okay, and assign the IP addresses, then only it will be easy for you to follow, okay, otherwise it will be slightly difficult for you. Now I am going, okay, so these are all the IP address I want to configure here. Okay, so let me start. I am going to 20.1 first. Okay, so before that I want to give you a very important concept, okay, a very important concept, because most of the students will do mistake in this. Okay, so what is that means? Okay, you can see a router to router, okay, router to router, if you see the connection, that means the link, the cable is in red color. Okay, router to router, the connection is available in red color. Okay, so what does red color, okay, why it is means, this is a type of cable and this is called, okay, serial cable. Okay, so this is called the serial cable. So if you want, I'll just make a note here. You can see router to router. If you are connecting a router with a router, so you are going to use a cable. What is a cable you are going to use means, you are going to use a serial cable. Okay, you are going to use a serial cable. The serial cable will be used. So serial cable is going to be red in color. Okay, actually here in packet tracer it will be red in color. If you go for the real time, in real time it will be blue in color. Okay, it will be blue in color. So here, okay, we are having the red color the cable is given. Now in a router to router connection, okay, so please watch this carefully. In a router to router connection, okay, router to router connection. So in one place, okay, you take any router to router, in one place you have to fix what is the speed, what is the speed of this cable. Okay, if you miss this, your topology will not work. Okay, so in a router to router, if you take a router to router, so one end, okay, we have to fix the speed. The speed is nothing, we have to fix something called clock rate. Okay, something called clock rate. What is the clock rate? Means the speed in which it transfers the data. So only for router to router, only for the serial connection, okay, only for the serial connections we have to fix the clock rate. So clock rate you can fix it as the default clock rate is 64,000 is the default. You can increase, you can decrease, so based on the speed will increase, but the default clock rate is 64,000 is a default clock rate. Okay, so this is the concept. It's not a big thing. I am going to do it now. So if you see, you will understand better. Now what I am doing means I am going for, okay, keep this in your mind, router to router we need to fix the clock rate in one place. Okay, now this is router to router. Now if you keep the mouse on the interface, okay, if you keep the mouse on the interface, now you can see carefully, it is giving the hint, it is serial 2 by 0, serial 2 by 0. With 2 by 0 you can see there is a clock symbol is coming. Okay, there is a clock symbol will come. Okay, so it is just, okay, fraction of second it is coming and going. So this is 2 by 0, serial 2 by 0 with clock rate. With clock rate you can find there is a small round, okay, like a clock symbol will come. Okay, so this is going to be serial 2 by 0 with clock rate. So we have to fix the clock rate for this. Now if I fix the clock rate here, the other end no need to fix it. Okay, no need to give it. Okay, actually there is a concept available. Okay, what is that means? It is called DTEN, DCEN. Okay, one end, this is one end called the DTEN, the other end called the DCEN. We will see this in the theory part. Okay, we are going to discuss it in the theory part, so no need to confuse now. So one end there will be a clock rate, the other end no need to fix the clock rate. So now how can I find this, teacher? You can just keep the mouse, you will find, okay, serial 2 by 0 with clock rate. Now I click the router, I am going for serial 2 by 0, serial 2 by 0. Now IP address. So what is IP address means? We already, okay, we already noted the IP address. So this is going to be 20.0.0.1. Okay, 20.0.0.1. So this is the IP address. Subnet mask 255.0.0.0 is the subnet mask. Okay, then you have to fix the clock rate. You can follow the mouse, clock rate. Now what is the default clock rate means? The default clock rate you can change the clock rate and you can see the effect, but the default better to go with the 64,000 is the default clock rate. So I am going for 64,000 and then make the port status on. Okay, make the port status on. So only in one end. Okay, now I am closing this. So in this link, that means R40, R4 to R0, in this 1 will be the clock rate. So this is the clock rate. Now let me go to the next hint. So here it is serial 2 by 0. Okay, you can keep the mouse here, it is giving the hint 2 by 0, but no clock rate here. Okay, now I click the router, go to the config, serial 2 by 0. So IP address. So what is IP address means? We already noted here. So the IP address is 20.0.0.2 is IP address, subnet mask. So here you no need to fix the clock rate. Suppose by mistake if you click the clock rate, nothing, no need to worry, no need to worry. But in this place if you miss the clock rate, it's a issue, it's a problem. So here we no need to fix the clock rate, but I gave the clock rate means it will automatically ignore. Okay, it will automatically ignore, so it is not going to worry about it. So now you fix the clock rate here or you miss the clock rate, no need to worry about it. So not set, I am not giving the clock rate. Okay, now I make the port status on, and then I'm just going to close this. Now you can see, so the two ends, okay, it is now started. Okay, it is now turned into green color. Okay, it is turned into green color. Now the same steps I am going to repeat. Okay, I am going to repeat for all the, okay, router to router connection. Now I am going here from router 0 to router 3. Okay, here you can keep the mouse here. Serial 3 by 0 clock. Serial 3 by 0, okay, clock rate. So now I click the router. I am going serial 3 by 0. Okay, so what is IP address means? This is 30.1. Okay, now I am giving 30.0.0.1 is IP address, subnet mask, then clock rate. So clock rate is default 64,000 is a default clock rate. Then you can make the port status on and close it. There. So go to the next interface. So keep your mouse here, 2 by 0, serial 2 by 0, but no clock rate. Okay, it is not showing any clock rate. So click the router, go to serial 2 by 0, IP address. So already we noted the IP address here. Okay, it is 30.0.0.2. So 30.0.0.2, okay, subnet mask, make the port status on. So now you can see, so this is also now switched on. Then let me go to this place, that means from R4 to R1. Okay, so I keep my mouse, the pointer here, it is showing 3 by 0 clock, 3 by 0 clock. Okay, so yeah, just confirm it. Yes, 3 by 0 clock. Now go to the router, 3 by 0. So IP address we already, okay, noted the IP address here. So it is 70.0.0.1. Subnet mask 255.0.0.0. So clock rate 64,000 is a default clock rate. Then make the port status on. Good. Next one. So we are going for this place. Keep your mouse. Serial 2 by 0. Serial 2 by 0, but no clock rate because already we fixed the clock rate here. So on 100% sure, no clock rate here. So go to the serial 2 by 0. Okay, IP address we already noted here, 70.0.0.2, 70.0.0.2, subnet mask, make the port status on. So now we completed this particular part also, it is over. So we have another only two, okay, two connections only. Keep your mouse here, 3 by 0, it is serial 3 by 0 clock rate. So click the router, go to serial 3 by 0, IP address. So IP address is 60.1, 60.0.0.1 is IP address. Then subnet mask 255.0.0.0. So this is clock rate. Okay, so actually there is a technical name available for this. Okay, so DTEN, DCE end. Okay, I am not telling that, I will explain that in the lab class, sorry, theory class. Now I make this as a port, okay, the port status on. So I completed this. Go to the next one, serial 2 by 0. Okay, serial 2 by 0. So go to the config, serial 2 by 0. So IP address is 60.0.0.2. So 60.0.0.2, subnet mask, make port status on. So now you can see it is turned into green. So the last part, we have to go for the last one. So the last one here, okay, you can see serial 3 by 0 clock rate. Okay, so click the router, serial 3 by 0. So we have to fix the clock rate. The IP address is 50.1 is IP address. So I am giving the IP address 50.0.0.1 is IP address. Subnet mask, make the clock rate, okay, clock rate 64,000, make the port status on. Then I am going for the last one. So the last one is 3 by 0, serial 3 by 0, but there is no clock rate here. So go to serial 3 by 0, IP address. So the IP address is 50.0.0.2 is IP address, subnet mask, then make the port status on. Okay, so we completed the configuration. So all the IP, okay, whatever the IP address needed, we completely assign the IP address. Okay. Now, okay. So the next step is we have to check whether the packet is moving or not. Okay. For example, from PC 0, I am going to send a packet, okay, to PC 5, and I want to check whether the packet is moving or not. So how we can do this means I am going for the simulator. Okay, I am going for the simulation. Okay, so simulation window is available. Just if you click that, okay, you are getting the simulation. Now in the simulation window, I am going to click the edit filters, okay, or show all or none. Okay, you click this none. I am not selecting any protocol. So these are all the protocols you can check. There are plenty of protocols you can check: ACL, ARP, BGP, CDP, DHCP, DNS, plenty of protocols we can check it here. But I don't want any of the protocol. Now I am going for the edit filters. In edit filters, I am going to take only one protocol. I am going to take, that means I am going to take ICMP protocol. Okay, teacher, why you take ICMP protocol means, so the ICMP protocol is used for ping command. So there is a very popular command, ping, P-I-N-G. So the ping command is a part of ICMP protocol. So I just select the ICMP. So now only the ICMP protocol is selected. You can see the screen now, you can see the mouse pointer. So I selected only the ICMP protocol. Okay. Now I want to test the connectivity. Okay, I want to test the connectivity. So how I am going to test means I am going to click this. This is called the PDU. So you can say it is a packet. So I am taking the packet. Now from PC 0 to PC 5, I am going to give a ping command. Okay, PC 0 to PC 5, I am going to give a ping command, and then you just give auto capture. So if you give auto capture, you can see what is happening. The packet is going to start from PC 0. It is coming to the router. It is coming to the router. Now in the router, it is asking, okay, or it is telling, I want to go to 40 network. Okay, I want to go to 40 network. Now this router is telling, I don't know where is 40. I don't know where is 40. So for about 40 network, I don't know any information. So please you go back. Okay, you please go back. Okay, it is sending you the back. Now you see, I repeat again, from PC 0 to PC 5, I am giving the ping command. I just give the auto capture. So the packet is going from PC 0 to router 4. From the router 4, the packet cannot move. Okay, you see the red color. So the red color is a error. Okay, you are getting the error message. Okay, you are getting an error message. That means I don't know where is 40 network. So the reply is coming to you, and you can see, okay, this is going to be a error message. Okay, teacher, it is not very clear. Can you show by using the ping command means? Let me show by using the ping command. You can see. Let me. Okay, so I am going to the PC 0 I am taking. Now I am going to the command prompt. So from the command prompt, I am going to use the command ping, P-I-N-G, ping the IP address of any computer available here, any PC. Okay, for example, 40.0.0.1. Okay, so from PC 0, I am giving a ping command to 40.0.0.1. This is 40.0.0.1. Now I am just going to enter. Now you can see here what is the reply coming means. The reply is destination host unreachable. Destination host unreachable. So we cannot reach. Okay, from where? From where the reply? The reply is coming from 10.0.0.10. So 10.0.0.10 is nothing. This is the gateway. 10.0.0.10 is telling, okay, destination host, okay, unreachable. It is not possible to reach that person. So your packet is going up to PC. From PC 0, the packet is going up to your gateway. From the gateway, okay, the packet is coming back. Okay, the packet is coming back. Now I want to give ping command from PC0 to PC1. I want to give a ping command. Okay, from this place, from PC0 to PC1, I am going to give the ping command. So that means ping 10.0.0.2. I am in 10.0.0.1. This is 10.0.0.1. From 10.0.0.1 to 10.0.0.2, I am giving a ping command. Okay, I am giving the ping command. Now you can see here, now I am getting the reply. So reply from 10.0.0.2, reply from 10.0.0.2. So that means the packet is reaching 10.0.2 and 10.0.0.2 is giving the reply to you. Okay, it is giving the reply to you. So this connection is working. That means inside the network it is good, but between the networks, from this network to this network, okay, your packet is not moving. Now, how to solve this problem? Okay, how to solve this issue means, so this is called, okay, a routing problem. So now we are going to discuss the lecture, the next lecture for us. Okay, that means lecture number 12. Okay, 12 or 13 I forgot. The next lecture is routing concept. So what is routing? What do you mean by routing? Routing means moving the packet from one network to another network. I want to move the network from, I want to move the packet from one network to another network. If you move, so that is going to be the routing. So between the networks, your packet must move. Okay, now if you go for routing, there are two different types of routing available. Okay, so the first routing is static routing concept. The second one is dynamic routing. Okay, so dynamic routing concept. Now in this course, we are going to study only about the static routing, and for dynamic routing, okay, we are going to see some protocols. Okay, we are not going to study all the protocols. So only some protocols we are going to study, only one protocol, not some, even only one protocol we are going to study. Okay, let me repeat the point. Routing, there are two different types. One is the static routing and second one is the dynamic routing. Okay, so for static routing, okay, you can create a static routing here. Okay, so I am going to explain this. For dynamic routing, you are having some protocols. There are a lot of protocols available, but here we are going to study about only one protocol. The name of the protocol is called RIP, R-I-P, RIP protocol only we are going to study. Okay, now in this topology diagram, so now what I am going to do, I am going to make a copy of this, because in the same topology diagram I am going to do static separate. In the same topology diagram I am going to use dynamic routing. I am going to configure. Okay, try to understand the concept. So static routing I am going to apply for the same topology diagram, and for the same topology diagram dynamic routing also I am going to configure. So I am just going to make a copy of this. Okay, save as. So I am going to make this as, for the first one is the static. So I make this as a copy, static available. One more copy I am going to take the same thing, I am going to make it as, okay, dynamic. So dynamic. So I took two copies of this topology, okay, of this packet tracer file. So one is for static and one is for dynamic. Okay, now let me open the static now. Okay, so let me open the static and I am going to do the static routing. Okay, so this is for static I am taking, my file name is static.pkt. Okay, now what is static? What is static means? Now I am the administrator. The administrator is going to create, his own path. The administrator is going to create a path. So how you can see, from router 4 to router 0, I want to create a path. I want to create the path, okay, manually. So the administrator is going to create manually, okay, the administrator is going to create the path. You and me are the administrators, okay, you and me are the administrators. Then from here to here I want to create a path. Then my packet will reach the destination network. The packet will reach the destination network. Then while coming back reverse, so I want to bring my packet in this direction. I want to make a static route. Okay, I am going to make like this. I am going to create a path, okay, for my packets. So I want to send the packet in this direction. You can see the arrow mark. So it is going to this network. Then from here, okay, the packet should come in this direction. So this is called the static path. So static path means, or static routing means, the administrators can create manually. Okay, the administrators can create manually. Okay, they can create their own static route. Okay, we can see in the theory part, you will understand better. So static route the administrator will create manually. But in the dynamic routing, you no need to create. If you enable the protocol, just if you enable the protocol will take care. You no need to create. Okay, we are going to see it now. So let me go for the static route now. I want to configure the static route. Okay, now I am going for this machine. Okay, PC, that means router 4. I am going to click the router 4 because I am the administrator. I am creating a static route now. Go to config. Go to config. Now in config you can see there is an option available, routing. Okay, so routing is an option. So under the routing you are having static and RIP. So static routing, RIP is dynamic routing. RIP is dynamic routing. So now I click static because I want to create static routing. Now network, what is your target, the destination, where do you want to go, means you can see the diagram carefully, do it in a very careful way. So from here I am in 10, from 10 to my destination is 40, I want to go to 40 network. So my network is, that means my target, where I want to go, target or destination. So the destination network is 40.0.0.0, that is my destination network. Then the next one is mask, subnet mask 255.0.0.0. Then the next one is next hop. Next hop means I am in this router, I want to make a jump. Okay, I make a jump to this. This is called the hop. So the next jump I want to go to 20.0.0.2. Okay, so you have to do it in a very careful way. Okay, it's not a difficult one, it's easy, but do it in a careful way. See, I'm here, my destination is 40. Okay, this is 40. Subnet mask is 255.0.0.0, well and good. Then what is the next hop, where you want to make the jump, means I want to jump, okay, up to this. Okay, so this is called the next hop. You can enter these 3 data and then you can just give add. So if you click add, okay, you can see, okay, it is now added. Now if you check by using the simulator, okay, your packet will move now up to this, your packet will move up to router 0. So if you want to check, you can check it. Now I am going for the simulation. I just take from PC 0 to PC 3, I am giving the ping command. Now you can see I just give the auto capture. We created a static route here. Up to this we created a static route. So the packet will go to the router. So in the router the packet is asking, I want to go to 40 network. Now, so now the route, okay, it is available. So it is forwarded up to R0. So we created the static route up to R0. Okay, now the same process we have to repeat in all the routers, so that we can have the static route. Now let me go to the simulation, sorry, real time. Now I am going for the next router. So we have done the configuration here. Now I go to the next router. In the next router I am going for the configuration. So static network. So what is the network? Means my destination is 40.0.0.0. Then what is the mask, subnet mask? 255.0.0.0. Then I want to make a jump from here. The next hop I am going to jump to 30.0.0.2. So the next hop is going to be 30.0.0.2. So now I am writing 30.0.0.2 is my next hop. So the next jump is 30.0.0.2. Now I am going to add. So now we created a static route, okay, up to this. So up to this means it will reach, okay, it will reach, okay. For example, because here the 40 is directly connected, so now your packet will go up to PC3, it will go. Then the packet will come back and then the packet will be dropped in this place. I want to check that, I want to see this, okay, yes, you can see this. I am going to the simulation. So in the simulation I am giving a ping command from PC0 to PC3, I am giving the ping command. Now you can see it will go to the router 4. From the router 4 we already created the static route. Router 0 to router 3 we created the static route. So if it comes to router 3 already, okay, automatically it will enter because it is directly connected. So automatically it is going to enter here. Then the PC3 will give the reply. Now the reply will be dropped here in this particular place. So you want to check that? Yes. So you can just give the auto capture and you can see how the packet is moving from router 4, okay. So from router 4, so the packet will be forwarded to router 0 because we created the static route. Then from router 0 to router 3 also the packet is going to move, we already created the static route. Then from router 3 to PC3, okay, first time, teacher it is not moving, no need to worry. The first time you will get this error. This is because of some protocol, name of the protocol is called ARP, okay, ARP protocol. So this you will understand it later. So now I just delete it and again I am going to give the same ping command I am going to give, okay. So nothing, no need to worry about it. So PC0 to PC1, the same thing I am giving. Now you can see you will get that error only first time because of some protocol, it is called ARP, address resolution protocol. It's a big thing, I will explain that later. Now so the packet is forwarded from router 4 to router 0, then router 0 to router 3, then router 3 to PC, it will go to PC3. Now from the PC3 you will get the reply, okay, from the PC3 you will get the reply will be dropped. So the reply is coming. Now you just think, okay, think in an alternative way. Now so the packet is coming to the router. Now the router is asking where do you want to go, the router is asking where do you want to go. So now the packet is telling I want to go to 10 network, okay, while coming back it is 10, the destination network is now 10. So now it is checking in the routing table, there is nothing for 10, so the packet is dropped, okay, the packet is dropped. So we have to create the route again. I am going for the real time, okay. So you can see the things now, okay, in a very easy way. Now I am going to this router, then I am going for the command config, I am going to have the static route. Now what is my destination now? Means my destination is 10, I am going to come back reverse, okay, I am going to come back. So in the reverse, so now my destination is 10.0.0.0, okay. Then subnet mask 255.0.0.0. Then the next hop, what is the next hop means? You can see here we are in this router, the next hop, the next jump is here, it is 50.0.0.1. Now the next hop is 50.0.0.1 is the next hop. Now I just make it, okay, make add, you can add it. So now your packet will come, that means it will reach the PC3, then the reply will come to the router 3, then up to router 2 your packet will come. Okay, no need to check, okay, automatically it will work. So now I am going for this router, click the router, go to the config, static. So the destination is 10.0.0.0, subnet mask is 255.0.0.0. so next hop, so yeah, tell me. Okay, it's a very good question. I take my car, okay, I'll just close it, no problem. I take my car from Sur, this is Sur, okay, this is Sur, this is my house. From my house or from my flat, I'm driving my car, I'm asking this person, okay, that means here I'm telling I want to go to Muscat. Okay, now what is my destination means? My destination is Muscat. My destination is 40, this is Muscat. Now I'm taking my car, I want to go to 40, yes, I want to go to 40, go like this. Now I reached Muscat. So while coming back, reverse, so while coming back, okay, they are asking where do you want to go? I want to go to Sur. I want to go to Sur, okay, because my flat is available in Sur. So my destination is 10 now. Okay, while going in this direction, my destination is 40 network. While coming in the reverse, my destination is 10 network. Okay, 10 network. That is the reason we use 10 network here. Okay, we are giving the 10. So now I configured up to this router, I think. Okay, let me check, no problem. Okay, it's a good question. Now I am going for the router 2, static. Now where do you want to go? You want to go to Sur, that means you want to go to your home back from Muscat. So 10.0.0.0, then so subnet mask 255.0.0.0. Then what is the next hop means? I'm here, so the next hop I want to make a jump to 60.1. Okay, so you are going in the reverse approach now. So 60.0.0.1. Okay, 60.0.0.1, and you can add this, okay, automatically you can see the static route is created. Now your packet, now it will reach up to this. Next one, so click the router 1, go to the config, go to static. Now my destination is 10.0.0.0, subnet mask is 255.0.0.0. then the next hop, okay, I'm here, the next jump I want to make to 70.0.0.1. so 70.0.0.1 is my next hop. Okay, add it. So now, okay, our configuration is completed. If you give the ping command from PC0, okay, it will move like this, then it will reach the destination, any destination, then the reverse, the reply will come in this particular direction. Okay, you will get the reply. Okay, I want to check this, yes, so we will check this, okay, by using the simulation. So go to the simulation, so take a packet. So now I am going to give PC0 to PC3. Okay, so I am giving the ping command, and then I am going to click auto capture. So if you give the auto capture, you can see how the packet is moving. From PC0, the packet is going to the switch. So in the router, I am asking, I want to go to 40 network. Now they are telling, take a jump to 20.2. Okay, this is the next hop. Then from here, make a jump to the next hop, 30.2. You reached 40 network. You reached 40 network. So in the 40 network, your packet should go to PC3. Okay, so your packet will go to the PC3. So PC3 is going to give the reply. So the reply is going to reach the router. Now they are asking, where do you want to go now? My destination is 10 network. Okay, go to 10 network now. So they are forwarding it to the router 2. We created the static route like this. Okay, we created the static route like this. So now the packet is moving like this. So automatically it will reach the PC0. Okay, so we got the reply. So you may ask a question, okay, what does that means? Teacher, why you are sending in this direction and you are receiving in a different direction? Can I do this in the same direction? Means yes, okay, from R4 to R0, R0 to R3, again R3 to R0, again R0 to R4, you can do it. Okay, you can do it. So there is nothing, there is no issues available. So you can fix your own way. Okay, you can create, that means the administrators can create their own, okay, routes here. Okay, there is no restriction. Okay, in this case I have taken this example. Okay, I am sending from R4 to R0, then R0 to R3, then PC. So reply I want to, okay, take in the same path I want to give R3 to R0, R0 to R4 also, you can do it. Okay, so there is no restriction because the administrators can give any path, they can create any path as they like. So this is called static route. Okay, it's the concept of static route. So static route is difficult, but it is very strong. Okay, it is very strong. But whereas dynamic, I'm going for the dynamic now. So dynamic is very easy, it's nothing. Okay, there will be some protocol, the protocol will take care of everything, but dynamic is having lot of things. So there are next course, that means in the next semester you will study a course, introduction to routing and switching. Okay, it's a very important course for a networking student. So in the introduction to routing and switching course, you will completely study about these routing concepts. There are plenty of things available. Okay, so here we are just giving an introduction in this course. In the next semester, the huge thing, plenty of things you will study. Okay, now what I'm going to do, I just go to, I'm going to close this because we completed the static. So static is over. Now I'm going to open the dynamic. So I already made a copy of this, so I'm going to open it now. Okay, so let me start the dynamic, okay, static, sorry, dynamic routing. I'm going to start now. See, that is very easy. So the same topology, okay, the same topology diagram, I made a copy. Now in this, if you give the ping command PC0, your packet will be stopped here. Okay, if you give a ping command to the PC3, your packet will be stopped because there is no routing here. There is no routing concept, okay, configured in this. So just wait for few minutes. So let it turn into green. All are reading now. If it is turned into green, we can check it. Now see, all turned into green now. So I want to check. I am going to give a ping command from PC0 to, okay, PC3. I am giving the ping command and give the auto capture. Now if you give the auto capture, automatically your packet will be dropped here because there is no routing. So the packet will go to R4, router 4. So in the router 4, the packet will be dropped. You are getting the error message. The red color is the error message. Okay, destination host unreachable. Okay, destination host unreachable. So you are getting an error message. So the packet is now getting dropped. Now we are going to use dynamic routing here. Dynamic routing means you can have some protocol, you can enable some protocol, the protocol will take care of everything. Okay, the protocol is going to take care of everything. So we are going to use a RIP protocol here. Okay, so in dynamic routing there are different types available. All these things we are not going to cover in this course. Okay, because we are in lecture number 12, I think. In the next course, introduction to routing, you will study everything. Now, so I want to enable the RIP protocol. Very easy. What? Go to the first router. Okay, go to the first router. Go to the config. Go to the config. Now you can see there is a option called RIP. RIP. Okay, RIP. So in the RIP protocol, just you have to enable the RIP protocol, but you have to give the networks. What is that network means? Okay, please note down, directly connected networks. What are the networks directly connected here? So in this router, router 4, there are 3 networks directly connected. What are they? 10 network. 10.0.0.0, 10 network is directly connected, add it. Then 20 network is directly connected, 20.0.0.0, okay, because this side 20 network is directly connected, add it. Then this side 70 network will be directly connected, so 70.0.0.0, so 70 network is directly connected, finished. So just you have to tell the RIP protocol what are the networks directly connected, okay, what are the networks directly connected. So there are 3 networks directly connected, 10 network, 20 network, 70 network. So I configured that, so my job is over. Go to the next router. So this router, I am taking the next router, go to the config, RIP protocol. Now here what are the networks directly connected means 20 and 30. 20 network is directly connected and this side 30 network is directly connected. So I am giving 20.0.0.0, okay, add it. 20 network is directly connected. The other side you can see 30 network is directly connected, 30.0.0.0, okay, you can add it. So your RIP protocol, yes, tell me. I am going to the next router. So the next router you can see here there are 3 networks directly connected here. So what are the 3 networks? 40 network is directly connected, 30 network is directly connected and 50 network is directly connected. Then I just, okay, I am going to click that, go to the CLI command line interface. So in the command, so go to the config, go to the RIP protocol. So 3 networks directly connected here. So 40.0.0.0, okay, this is 40 is directly connected, add it, and this side this is 30. So 30.0.0.0, then here it is 50, okay, 50 network, so 50.0.0.0, okay, add it. So 3 networks directly connected, so I just added this. Now let me go to the next router. In the next router, okay, I am going for the config. So here there are 2 networks directly connected. What is that? 60 and 50. So this side 60 and this side 50. So now I am going for the RIP. So 60.0.0.0, 60 network is directly connected, and then 50 network is directly connected. Okay, so these are the 2 networks directly connected here. Now, so I completed this. Let me go to the next router. So here there are 2 networks directly connected, one is 60 and 70. So go to the RIP, so RIP protocol 60.0.0.0, then 70.0.0.0, okay, add it, okay, problem solved, finished. You can give ping command from anywhere to anywhere, automatically the RIP protocol will take care, okay, the RIP protocol will take care. If you ask me to explain how the RIP protocol is working, okay, all these things, it will take at least 10 hours. It will take at least 10 hours, I am telling, okay, it's a big concept. So here I just enabled everything, RIP protocol is now enabled. Now let me check. I am going to give the ping command from the first machine, from PC 0 to PC 3. So let me give the ping command. So just give the auto capture. You can see how the packet is moving. So packet is going to R4. Now this is dynamic. Dynamic means automatically it will select the path. Okay, automatically it will select the path. Why, teacher, it is going in this direction means this is the shortest path. This is the longest path. So the packet will not move in the longest, okay, because dynamic protocol will take decision. Okay, so I just delete again because of here first time you will get this issue. Now I give the ping command from here to here. You can see automatically it will choose the dynamic. Dynamic means the path which is the very shortest path. Okay, you see while coming back. Okay, you see the reverse, the reply, how the reply is coming. So it is going to the router 0. So from the router 0 to router 3, then it is going to reach the PC 3. Okay, so from PC3 you see the reply, how the reply is going to come. So always it will move only in the shortest path, automatically it will select the shortest path, your packet will be forwarded in the shortest path only. Now you can see the packet here, it is very important. Now you see from router 3 to router 0 the packet is moving, then from router 0 to router 4 the packet is moving, then from router, because this is the shortest path. Okay, so one hop, okay, this is hop, HOP hop. So this is one hop, this is two hop. So in two hops you can reach the destination, but here one hop, two hop, three hops, you have to make three hops, three jumps you want to make. So okay, I want to travel from Sur to Muscat. So this is the first roundabout, second roundabout, okay, you take it as the roundabouts. So one roundabout I crossed, second roundabout I crossed, I reached Muscat. But here I want to cross three roundabouts, first roundabout, second roundabout, third roundabout, then only I am going to reach. So now I am going to consider this path is the longest path. Okay, so this path is the longest path, so my packet cannot move. Now what I do, okay, so there are other things. What I am going to do now means, suppose if any problem, okay, suppose this link, this cable is not working, okay, the cable is not working because of some problem, the cable is not working means your dynamic routing protocol, so what it will do means it will select the alternative path. It will select the alternative, okay, your packet will go in this direction. Suppose if any issue available here, automatically it will go in the other direction. So this is called dynamic. So the RIP protocol, RIP, the RIP protocol is going to manage everything, okay, dynamically. So now if you want to check, okay, we will do, okay, we can check it, okay, I will show that. See, I am going for the router, okay, so this router I am going to make it off. Okay, I am going to switch off the router. Okay, so how I am going to switch off, you can see, let me zoom in. Now, so this router 0, I am going to switch off the power, electricity, I am going to switch it off. So I am going to the physical. So in the physical, okay, so we already know about the config. Now I am going for the physical. So in the physical, you can see there is a power button here. I am going to switch off, I am going to turn it off. Okay, I am going to turn it off. I switched off and then I am coming back to this topology diagram. Now you see it is turned into red because this path is not available. Now this path is not available because we turned off. Okay, this router is now down. Okay, now down. Now I am going to give the ping command. If I give the ping command from PC0 to PC3 means automatically your packet will be sent in this direction. Okay, so the RIP protocol will know this. The RIP protocol will know this because it is dynamic. So whatever the changes happening in your network, automatically it will find. So your packet will go like this, then you will get the reply in this direction. But in static, you created static like this. But in static, if any problem comes, finished. Okay, you cannot. Okay, you cannot send a packet. Teacher, can you give a ping command now? Let me check. So I am going for the simulation. I am going to give a ping command now from PC0 to, okay, so PC3. So I am giving the ping command. Now let me give the auto capture. Okay, so let me give the auto capture. Now you can see, yeah, automatically it is going to select a different path. So the RIP protocol, the routing protocol will help you to select the alternative paths. Okay, you can see now. So it knows, okay, it knows this particular link is not working now. So your packet should go in a different path. So a different path is now selected. So it is going to the PC4. While coming back also, it will use the same path. So this is dynamic. So dynamic routing protocols are very interesting things. Okay, you can see. So the packet has reached PC3. From the PC3 the reply is coming. So even though this is the shortest path, but the path is not exist now. So dynamically the RIP protocol is learning that. It is understanding that. Okay, so you will get the reply. So this is the concept of dynamic. Okay, so dynamic routing RIP protocol. Okay, yes. Now, so the packet has reached the destination. Okay, another 2 minutes.
Doctor,
Yeah, tell me.
now the way router 1 and 2, we take only for like reservoir or super.
No, I didn't get you. So this is how the dynamic protocol, okay, dynamic routing protocol is working. Okay, yeah, tell me. So what is that means? If this, okay, the route, we can say this is the route. So this route is not available now. Okay, this route is not available. So your dynamic routing protocol, it is going to use the alternative path. So in this path the packet is moving, and the, okay, in the same path the packet is coming. Suppose I am going to make this on now. Okay, you can see I just make the router on. Okay, let me make this router on. So if I make the router on, your routing protocol will change the mind. Okay, automatically it will change the mind now. Okay, you can see here. I am going to, okay, show that. Let me make, okay, it is on. It will take few minutes, okay, to do the configuration and all. Okay, so I made this on. It will take some time, okay, few minutes, okay, it will take. So you can see now, okay, everything is turned into green. So if I give the ping command now from PC0 to PC3, if I give the ping command, automatically it will choose the best path. That means the shortest path only it will use. So if you want to check, let me give a ping command from PC0 to, okay, again PC3. So if you give the ping command, now you can see how the packet is moving. So the packet is moving, okay, so it will choose the best path. So the dynamic routing protocol, so it will dynamically, it will read your topology diagram. If any changes available in the topology diagram, it will find it. Okay, so this is about the dynamic routing protocols. So we are going to study about this dynamic routing protocol in detail in the next semester. Okay, introduction to routing and switching. So now it will work. So this is, okay, about, okay, two things we discussed: how to create a static route and how to create a dynamic route. So what are the differences between this static and dynamic? Okay, so this is the concept of this particular lecture. So if you have any questions, you can ask me. I am ready to answer. I will send the video. Okay, so in after few hours I will send it.